Alright, in this video, we're going to be going over investigation 2.4. So, here, our first question is, what is the exterior angles of a polygon, and what do we know about the measures of the exterior angles? Right. Here's just some background information. Here's an example of these are examples of a concave polygon. Notice how the angles are caving in towards itself. And so some of the properties that we're learning aren't going to work with concave shapes. We usually want to work with convex shapes. Okay. So in this lesson, we're focusing on exterior angles, so angles that appear on the outside of a shape. So in previous lessons, we worked on interior angles, angles on the inside, but now we're working on exterior angles. Okay. So let's use one color to highlight the interior angles. So again, let's use blue. Any angle that are inside of the shape, those are going to be called interior angles. So notice how these arcs, these degrees inside the shape, we call these interior angles. And any angle that appears outside the shape, let's use a different color. Let's use red. These are called exterior angles. As the name kind of implies, exterior means on the outside. So these angles are on the outside of the shape. So that's an exterior angle. This arc, this arrow is an exterior angle. This arc is an exterior angle. So everything in blue is interior and everything on the outside is exterior. One thing you might notice that in order to get an exterior angle, notice how we're extending these lines here. Do you see how these lines are sticking out? So if I want to draw exterior angles, first I need to extend these lines. So we're on the line tool right now. So I'm going to extend each of these lines. It doesn't really matter which way we extend it, as long as we go the same way all the way around. So again, I can go this way if I wanted to. So here we have lines sticking out. Right? And after drawing all the lines that are sticking out, we can draw the exterior angles. So two more, one more. So let's draw the exterior angles, the angles that go on the outside. I'm going to switch over to the drawing tool again. And these are the angles that are on the outside. That's an outside angle. That's an exterior angle. That's an outside angle. Exterior, exterior angle, exterior, exterior. This is an outside angle, angle on the outside, angle on the outside. Okay. So again, those are the difference between the angles that are inside the shape and angles that are outside of the shape. So here, the example that we're looking at is this bike race. So while practicing for a bike race, they're starting on path A. And notice how they're going to travel the exterior of the shape. So they're going to wrap around this way to get back on the lane, ride their bike, wrap around the exterior, ride their bike, wrap around the exterior. So they're taking the outside angles in order to move all the way around the shape. So notice that we're moving in a circle. We're starting at point A, and then we face back to point A. So I'm guessing that the exterior angles are going to be 360. Oops, 360. Oops, sorry, wrong button. 360. We start the same way and end the same way. Okay. So let's go and actually measure and see if this is true. So for angle A, notice how we're stopping at around 40 degrees. Again, we're measuring the outside angles. So outside of here, angle A is going to be around 40. Okay, let's measure angle B. Make sure the protractor is in the center. Rotate it this way. Make sure the bottom is lined up. Is this around 75? Okay. Measure angle C. Make sure the center lines up. Make sure the bottom is along the bottom arrow. This looks around 90. Okay. Angle D. Let's measure this. Okay, let's see. Make sure the bottom lines up. This is kind of hard to see, but it looks like in between, here's 80, here's 90. Is this 85? 80? Oh, sorry. Let me move this. Oh, here's 90. Here's 80. Oh, sorry, 65? There we go. And this last one is outside angle is 1 or 95? No, 90. Okay. So now that we have all the outside angles, let's see what all the outside angles add up to. So 40 plus 75 plus 90 plus 65 plus 90. Yep, all 5 of those. Again, I just took those numbers and added them up. And it looks like all the outside angles add up to 360. All right, if you're not sure, we can use this to help prove. Notice that if I move the corners, I can create a different pentagon. So it can make a different shape pentagon. And if I move in the corners, Notice how all the corners combine to make a circle. So all of the outside angles combine to make a circle. And we know that a circle is going to be 360 degrees, right? And it doesn't matter if I make a different pentagon. So say if I adjust these, move that a little bit. For this one, notice that they still combine to get a circle, okay? The only reason this wouldn't work is if we have a concave shape. If it caves in, then this is no longer going to work, okay? So it only works when we have a convex shape, okay? So for the next examples, we're going to go ahead and measure these. So again, right here we have 110. Let's measure the outside angle. All right, the outside, again, starting from 0, counting up to, is that 100? Right, and measure C. Again, measuring the outside angle, so that's around to 150. Right, and if I add up all the outsides, see 110 plus 100 plus 150, looks like they all add up to 360. Okay, and as you can see, notice that the outsides of a triangle, even though it's a triangle, it still combines to get a circle, right? We still get a circle from the outside. Okay, let's try a different shape. So it works for a pentagon, works for a triangle. Does it work for a quadrilateral? Let's see, it looks like the outside angle for this one is 120. All right, let's measure B. Make sure the center lines up. Let's rotate it this way. So counting at 0, it looks like this is around 70 degrees. Okay, let's measure C. Let's rotate it this way. Looks like the outside angle is around 80 degrees. And let's measure this last one. Looks like this outside angle is around 90 degrees. All right, let's add all 4 outside angles and see what it adds up to. 120 plus the 70 plus the 80 plus the 90. And it looks like our pattern still stays true. And the angle, or all the angles from the outside, if I combine them, looks like they add up to 360. Okay, so again, here's a quadrilateral. If I combine it, yep, it makes a circle. Let's see if I make a rectangle. Let's see if I can make a rectangle. Or more of a square. So if I make this square, yep, still adds up to a circle. Okay. All right. We still get 360 from the exterior angles. All right, and next one. Let's try one last example. Here we have a hexagon. So let's see if the outside angles still add up. So this one's 80. Let's measure B. Move the center. Let's rotate. Looks like this outside angle is around 60. All right, let's measure C. All right, looks like this outside angle, if I line it up properly, looks around to be 30. All right, let's measure angle D. Make sure the center lines up. Again, we're measuring all the outside angles, right? So starting from the outside, curving in, looks like another 60. All right, let's measure angle E. Make sure that lines up, curve this out. So the outside angle, it looks like that's 100. And we have one more to go. Let's put this corner at F. Let's rotate this out. It looks like this outside angle is at 30. So adding all these up, 80 plus 60 plus 30 plus 60 plus 100 plus 30. Yep, looks like all the outside angles, again, I just added up all these numbers, adds up to 360. Right? And again, here I have a hexagon, and notice that when I combine the corners, it still makes a circle. Okay? All right, the exterior of a hexagon combined to 360, or a circle. Okay? So, would the turning pattern we observed occur for other polygons? Why not? So far it looks like it's working for every single shape. It worked for the hexagon, for a quadrilateral, for a triangle, for a pentagon. So my guess would be, I think this will keep working for other shapes as well. Okay, since it works for all the previous shapes, it will probably work for other shapes as well. Right? Every time we go from the outside, around the outside, we are making a circle every time. Okay, Let's move on to the next one. So here, one thing, when we figure out the interior angles, again, interior is different from the outside. To figure out the inside angles, we always did the number of sides minus 2, and then multiply that by 180. Again, the minus 2 part, that was telling us how many triangles we get. So we get 2 triangles in the middle, and each triangle is worth 180. So here I do 6 minus 2, and then times that by 180. If I have a 15-sided shape, I get 13 triangles, 15 minus 2, and then each triangle is worth 180. And here, if I plug in 32 for my x, so plug in 3, plug in 4, plug in 6, plug in 15, plug in 32. So these are the angles inside of each of these shapes. Okay. So let's think about how many supplementary angles do we have in this diagram. Remember that a supplementary angle is a straight line. So how many pairs of supplementary angles are there? So here's a supplementary angle, here's a straight line, here's a half circle, here's our supplementary, here's a straight line, here's a straight line, here's a straight line. Looks like there are 5 supplementary angles. There are 5 supplementary angles. Each supplementary angle is worth 180. So what's 5 times 180? Again, if I combine the in and outside angles, in and outside angles, in and outside angles, if I combine everything together, oops, sorry, wrong button. 5 times 180, looks like that's going to be 900. So what is T made up of? T is made up of both inside and outside angles. If I just want outside, or if I just want inside angles, I can subtract the exterior angles. So what I mean by that is, here, another way we can figure it out is, I can figure out how many supplementary angles we have, and subtract the outside angles, which is always going to be 360. So here we have another equation. 180 times 3 minus 360. 180 times 4 minus 360. 180 times 6 minus 360. 180 times 15 minus 360. And 180 times 32 minus 60. Notice that we're using a different equation, but notice these answers, 180, 360, 720, 2340, 5400. Isn't that the same as when we use this first equation? Aren't those answers the same? So what this part's asking is, even though we use 2 different equations, why did we get the same answer? So we can think of, what's 180 times 2? Isn't 180 times 2 360? Okay. So both of these formulas work because they are equivalent. Okay. Again, if I multiply 180 times negative 2, do you see how I get the negative 360 down here? So it turns out these equations are the same. Okay. One's just figuring out how many triangles we can make. This one is subtracting the outside circle, the ones that we're just working with. So here, we're going to skip E1. So skip E1. So what's an exterior angle of a polygon? So exterior angles are on the outside. They always combine to make a 360 circle. All right, let's answer these last review questions. So again, complementary means 90, supplementary means 180. Okay. So again, if this is 90 degrees, again, I know the whole corner is 90. If I subtract the 45 minus the 45, I see that my answer is going to be 45. Okay. Here again, I have another 90 degrees. Notice how it's a corner piece. So that's 90. And if I subtract the 72, get rid of that part, I know that x has to be 18. This part has to be 18. Okay. Let's try the next one. Here, another corner. Again, I know the whole thing is 90. If I subtract the 23, get rid of this part. Whatever's left over has to be the answer. This is 67. Okay. Here we have a straight line. We know a straight line combines to make 180. So from 180, if I subtract the 100, get rid of that part, whatever's left over has to be the answer. Okay. Over here, again, the whole thing is 180. The whole arc is 180. The whole thing is 180. If I get rid of the 76 part, get rid of that part, minus 76. I know that what's left over has to be 104. So x equals 104. Okay, and the last one again, this whole arc is 180. And if I subtract the part of the angle right here, the 34, whatever's left over is going to be the answer. That part is 146. All right. So again, if you have any questions, feel free to let me know. But I hope this video helped.